vectors in parametric form. Now what we're going to do in this section is we're going to find a parametric form of the last vector we found. The vector OR in component form was vector XY is equal to vector OA in component form was X1, Y1 plus vector AR times T. In component form it was X2, Y2 times T. To recap on this equation, the vector OR was the vector we are tracking from where I am standing to where the vector is at time t. So this is where I'm at. This is where the object is at any given time t. How I track this vector is from where I am standing to my initial sighting of the vector. In component form is x1, y1. So here I'm at, and this is where I first spot the object, plus the velocity vector. In other words, this is where the vector started, this is the direction it's going at any given time t, or x2, y2. And t is just a particular time. So to find the component form of this vector, to find the parametric form of this vector is very, very simple. First thing I'm going to do is take this vector and transfer it over to the next page. There we have it. First thing we do is we just distribute the t to our x2 and y2 component form vector, which yields the following equation. Vector xy is equal to vector x1, y1 plus vector x2 times t, y2 times t. Simplifying that, just getting rid of the parentheses right here, leaves us vector xy is equal to vector x1, y1 plus x2t, y2t. Now to write the parametric form of the equation, what I do is I separate my two components into two separate equations. My first component is the x component. So the x component will equal to the x portion of my components, x1 plus x2t. The y component will equal my y components of the vector. So y is equal to y1 plus y2t. And this is what we call the parametric form of an equation. It allows me to see what is going on east and west, that's my x component, and what's going on north and south in two different modes. For instance, if all you want to know how an object is traveling easterly or westerly, I omit this portion of the vector because I don't care about it. I just compute my east and west direction. Nice thing is that I no longer have to compute x and y and x and y and x and y. Likewise, if all I care about is how the object is going north and south, I don't have to deal with my x component. I just work with the y component because the y deals with north and south direction. Now before we do more work on parametric form, let's just do an example on how to find a parametric form of an equation. I'm going to work with the last example we did, the lighthouse and the boat and how we tracked it. Well, that equation, so what we're going to do is we're going to take this equation, and we're going to write it in parametric form. If you were following the videos, the equation OR was equal to the vector negative 20, 35 plus t negative 5, 10, negative 5t. What we want to do is we want to write vector OR as a parametric equation. Before we do so, I'm going to write OR in component form. So I'm going to let vector OR equal to vector XY. Remember, component form is writing a vector as a matrix. So that will yield the equation XY is equal to negative 20, 35 plus vector 10, negative 5t. Now again, the first thing I do is I distribute the t to the x component, and I distribute the t to the y component, which yields this next equation. xy is equal to vector negative 20, 35 plus vector 10t, negative 5t. Now, separating it, I let the x component portion of my vector equal to the x component. So that means that x is going to equal negative 20 plus 10t. And then my y component of the vector will equal my y component, my y component of the parametric form will equal to my y component of the vectors, which gives me negative 35 minus 5t. And this is our parametric form of this equation, of this problem, and this equation. Now let's put this equation into practical use. Question: when will the boat be directly north of the lighthouse? Before I begin, I'm going to need some equations. Fortunately, we already know what the equations are. The vector from O to R is equal to vector negative 20, 35 plus vector 10, negative 5t. Or I could write it with the parametric equations. X is equal to negative 20 plus 10t, and y is equal to 35 minus 5t. Now what the question states here is, when will the boat be directly north of the lighthouse? Right here I have a little condensed version of the diagram. So we want to find is at what time this boat will be directly north of our lighthouse. So in other words, we're looking for the time when this blue vector will look as such. So the first thing I do is I look at my picture. And looking at this picture, I'm trying to find out at what time will this boat be directly north of the lighthouse. Well, first of all, using the parametric equation, how far is this boat east or west of me? And you can see it's 0 units, so that means that x is 0. How far north is the boat of me? Well, according to the picture, it looks like it's about 5 units. It's at 5. That's a guess. We're not exactly sure. So we don't know exactly what y is. Now, because I don't know what y is, I don't have to deal with it. I'm just going to deal with what I know. X equals to 0. Using the substitution property and plug it into our x form of the equation, 0 is equal to negative 20 plus 10t. Using the addition property of equality, I end up with 20 equals to 10t. Using my multiplication property of equality, remember, I'm multiplying by 1/10, giving myself a little bit more room, 2 is equal to t. Or, in 2 hours, the boat will be directly north of the lighthouse. Now, to see this pictorially, let's look at our picture here. Remember, this is how the boat is traveling. In 1 hour, the boat will travel right here. In 2 hours, the boat will go another one of these distance and will be right here. And as you can see from this vector, this is how the boat travels. In 2 hours, the boat will be directly north of us. Well, that concludes this video. Please watch the next video.